So let's talk about glaciers here today. And glaciers are a type of surface water. They just happen to be fresh water that's frozen on the surface. Now we're going to define what a glacier is, and I need you to pay very close attention to this and write the definition down very careful, because I have worded this pretty precisely. And that is that a glacier is a slow moving, key here is moving, mass of ice on land. How they're formed is from snow that piles up and squeezes itself into ice. But the key is it's ice, it's moving, and it's on land. Icebergs are not glaciers, even though they came from glaciers, because they are not on land. Now let's look at some examples of glaciers. There are two types of glaciers. So our first type of glacier is called a mountain or valley glacier. It's found in the mountains. It tends to form as ice in the valleys between mountains. Snow piles up, makes ice, and it starts to slide downhill in the gaps between mountains, which are valleys. And you see how the ice is dropping down to the low point down there, where it basically ends because it melts and it's no longer ice. Here you can actually see, get a sense of, ice forms up here and it flows downhill, just like liquid water would, but it's ice. Another great example of what a mountain or a valley glacier looks like, where the water looks like it's flowing downhill, just like liquid water, but it's actually ice. Just like liquid water can have tributaries and confluences, we see the same thing with glaciers. We've got a glacier that was going this way, another glacier that was going this way, and they met up down here, where we can have tributaries to a larger glacier, and where they meet would be a confluence, just like a river.
So notice that collection of ice out there. That's an example of a glacier. That's a place where snow has accumulated over time, piled up, squeezed itself into ice, and is now slowly moving downhill. Now, this particular type of glacier is called an ice sheet because it's not on top of a mountain. It is just a wide, flat sheet of ice, but it's still a glacier.
Now, how thick can this ice be? Well, in an ice sheet, which tends to be bigger than the mountain and valley glaciers, like in Greenland or Antarctica, the ice can be up to a mile thick. I like this picture because it's got a cruise ship, and if you've ever been on one of these, you know how big these things are. And there's the end of the glacier right there behind it. So we're not talking about little chunks of ice, they're quite large. Here's a group of people walking up a glacier, and just to give you some sense of scale about how big and how thick this ice can be. Here's a picture with two people or three people standing beside the thinnest part, or the tongue of the glacier, where it's at its end point. So these are very large chunks of ice. Now, where are these found? They are found on all continents except Australia, including at areas near the equator. Now, how can you have a glacier near the equator where it's warm? The trick is it has to be at the top of a very high mountain, where we know it tends to be cold. In the United States, we have glaciers in these continental states. In other words, not counting Hawaii and Alaska, in the main part of the United States, the lower 48. What do all these states have in common? They're all in the West, because these are the places where they have high enough mountains that it can remain cold enough year-round for a glacier to form. But Alaska has more glaciers than any other state, up to about 600 glaciers that are big enough that they actually gave it a name. Here's what Alaska looks like from the air. A good portion of the state is covered in these glaciers. One of the most popular things to do in Alaska is you take a cruise or a tour to where the glaciers meet the ocean. This is actually Glacier Bay National Park in Alaska. You can also take a flight. You can land planes right on the glacier. Mount McKinley, which is the tallest mountain in the United States, tallest mountain in North America, this is how the climbers get up to the point where they start climbing the top of the mountain. They take a plane up there and it lands right on the ice. Some places you can just walk right out there to the edge of the glacier. This is Seward Glacier, another good example of a mountain or valley glacier. This is Juneau, Alaska Mendenhall Glacier. Now there's some significant other locations outside the United States. First of all, Greenland. Greenland is basically one big huge ice sheet. It is one big huge glacier. This is what Greenland looks like from the air. The only parts of Greenland that are actually land like we know it are the parts around the coast. Iceland. There's about 269 named glaciers in Iceland, big ones, small ones that come together, and it covers about 11% of the whole country. Here you can see an example of a mountain or valley glacier coming downhill. The end here, Jökull, means glacier in Icelandic. So this is the Fla Glacier here in Iceland. You can walk right up to the end of it. And I show you this picture to demonstrate to you that this is not snow. It looks white from a distance, but it's not snow. It's snow that has been compressed into solid ice. So a glacier is not snow, even though it starts as snow, it's solid ice. You can go up and you can touch, you could even lick the ice out of a glacier. And because water gets into a glacier and stays there a long time, this ice or this water could be thousands of years stuck in that glacier. Hiking on glaciers is a popular tourist activity in Iceland. And to walk on ice, you know, ice is slippery, you have to wear things like this on your shoes. You have to carry an axe just in case you start to fall and you can jam it into ice and catch yourself. You also wear helmets because if you fall on the ice, you can hit your head, give yourself a concussion. Now, Antarctica is like Glacier Central. Over 90% of all the Earth's glacial ice is found in Antarctica. Not a huge tourist destination because let's face it, not many people get to Antarctica, but that's where the majority of the Earth's glacial ice is found. Now, these are moving. The question is how fast. Glacier movement is described basically with the word slow. We're talking like centimeters per day. Most glaciers basically just crawl. Now, glacier formation, all glaciers go through the same process. First, it's got to snow a lot. And we're talking not just a little snow here, we're talking copious amounts of snow. And the snow piles up into big, huge drifts up here, hundreds of feet thick. Well, the second part of this is that all of that snow gets heavy and it squeezes itself together under its own weight into ice. It doesn't fall as ice, it falls as snow. And all of the weight of the layers of snow squeeze itself together and make solid ice. Well, remember, it's got to be moving, and gravity works. So as the snow piles up, makes really heavy ice, gravity starts to pull the ice downhill. It starts to slide downhill. Whether it's a mountain glacier, valley glacier going down a really steep hill, or it's an ice sheet that is just slowly being pulled down a very slight slope towards the ocean, either way, gravity works to pull the ice downhill. Finally, you get to the bottom, and the ice either melts when it gets warm, especially in the summertime, or when glaciers hit the ocean, the ice breaks off because the ocean's going to be a little bit warmer than that glacial ice. We have a couple distinct areas with a glacier. We have what's called the zone of accumulation. That's up here where it is cold. And that's where snow is falling and the glacier is gaining its ice and its snow. The zone of ablation is the area down here where it gets a little warmer and the ice starts to melt. So the zone of ablation is the area where the glacier is losing its ice. Calving. This is what we call the process when the end of the glacier hits the ocean and big chunks of the ice break off. This is an example of what it looks like. If you're ever near the tongue of a glacier, which is what we call the end of it when it meets the ocean, you can actually hear this start happening. If you've ever taken an ice cube and dropped it into a cup of water, you hear that kind of cracking and popping sound. This is what happens when the glacier hits the water. And you get these big solid cracks that go through the ice, and it pops, and eventually it breaks apart and the ice falls into the ocean. That's actually how icebergs are formed. So icebergs were part of a glacier, but then they broke off. And at that point, they stopped being part of the glacier because they're not on land anymore. Now, glacial advance and retreat. An advancing glacier is one that's getting snow and ice a lot faster than it's losing it. So the glacier is getting bigger. One that's retreating means it's losing ice faster than it's gaining it, so the glacier is actually getting smaller. When we talk about global warming, one of the evidences that the planet is getting warmer is that we look at some of these glaciers over long periods of time. We see that now the glaciers are a lot smaller than they used to be. So overall, these glaciers are melting faster than they're freezing in the wintertime. So here's an example of the Muir and Riggs glaciers in Alaska, and you can see in 1941 the ice was way down here. It was actually way off the frame, and now the glacier only comes to there. So these are examples of retreating glaciers, glaciers that are getting smaller. They're losing ice faster than they're gaining it. Not all glaciers are retreating. The Hubbard Glacier in Alaska is actually growing, and it might actually close off the mouth of the Sitka River, at least periodically. And that's a big deal because people in Alaska live up this river and they have to get out to the ocean for their livelihoods. They're mostly fishermen. So if this glacier were to cover up the mouth of the river, it's going to cut off these people's access to the ocean. Ice Age. Now, we're not talking about the movie here. What an ice age is a period of time when the Earth was colder. And that means more of the Earth was covered by glaciers. Well, how many ice ages have we had? There have been at least 5. And the last one ended about 10,000 years ago. And we still don't really understand how they begin and end, but we do know that this happens. There's a prediction that the next ice age is going to begin in about 23,000 years. So don't hold your breath and expect to see it. We do know where the last major ice age came to. This area here in red on this map shows us the extent of the last ice age. That was the part of the country that was covered under glaciers 10,000 years ago. We see all kinds of evidence of where glaciers used to be. 10,000 years ago, those glaciers started to retreat. They got to a certain point, got as far as they got, and then they started to retreat because the planet got a little bit warmer and we came out of an ice age. Well, when the glaciers started to retreat, chunks of ice fell off of them, just like the chunks that break off in the ocean. If the glacier goes back fast enough, it would drop a chunk of ice. Well, ice is heavy. Water's heavy. So that ice would kind of sink into the ground. Well, it makes a hole in the ground. And over time, it's not going to be ice anymore. The ice melts, and we get a little hole that's filled with water. That's a lake. This is specifically called a kettle lake because traditionally they look like little circular kettles, like you think about like a witch's kettle. A lot of them were very perfectly round. You can see the kettle lakes in Minnesota, and you can see how they look very, very circular. These were all chunks of ice that broke off from the glacier at the end of the last ice age and were dropped right there in that place. The ice melted, the water stayed there. Of course, it rains, and water still goes into the low points, so we're left with this pattern of kettle lakes in places that had glaciers in the last ice age. Now, where would you see these kettle lakes? You're going to see them in the upper Midwest in Canada. You're going to see them upper Midwest and up here in Canada because those were the areas that were underneath the glaciers at the end of the last ice age. So those are the places where the water was dropped from the glaciers and it sunk into the ground and made those little lakes. Now, let's take a look at the kettle lakes in Georgia. There aren't any because the last ice age, the glaciers never got this far south. So there was no chunks of ice to break off the glacier. Now, what effect does this ice age idea have on the world's water? The amount of ice that's in glaciers greatly affects the sea levels. If there's more water frozen in glaciers, that means there's going to be less water in the oceans and the sea level would be lower. We know that Florida and the Gulf of Mexico had a coastline where that light brown area is out here about 10,000 years ago. Well, now we know that Florida's coastline is right there. So all of this area here was dry land during the last ice age because the water that's there now was frozen in the glaciers. Well, how do we know that that was dry land? If you go out there and you go scuba diving in this area, you can actually dig up fossils of plants and trees and land animals, which tells you that area was dry land. Remember, the amount of water on our planet is constant. It's not created or destroyed. So the water that now covers up that land must be somewhere on this planet or was somewhere on this planet different. The only place it could have been was locked in glaciers. Now, the flip side of that is also true. If all the glaciers on the planet melted, we'd get a lot more water in the ocean and sea levels would rise. And we know that this has happened in the past. We know that Florida has been underwater. We know that middle Georgia used to be on the coast. That's right about where I am from originally. And I know that down here in middle Georgia, you can find in the ground shark's teeth. Well, you're way away from the coast. The fact that you can find fossils of saltwater fish and you can find shark teeth tells you that South Georgia used to be in the ocean. And the only way that could happen would be if there was more water in the oceans, which means there was less water in the glaciers. And we know the planet has done this over time. It's gotten hotter and colder where there's more and less ice in the glaciers, and that affects how high the oceans are. Now, if the planet continues to get warm, we know that more of our glaciers are going to melt. And there are places in the world, especially near the coast and most of Florida, that might end up underwater if too much glacial ice melts.